Hi, welcome to Join the Data Movement with MongoDB Atlas and Confluent Cloud. I'm Robert Walters, a product manager on connectors and things at MongoDB. On the phone with me, I have Jeff Bean on the solutions team at Confluent. Today, we're going to talk about Apache Kafka, the Confluent Cloud, and deep dive into Kafka Connect and the MongoDB Connector for Apache Kafka. We'll have a few demos and have the opportunity to answer questions at the end of the presentation. So what is Kafka? Kafka is a distributed streaming platform written in Java and is the creation of former LinkedIn data engineers. In 2011, the technology is handed over to the open source community as a highly scalable messaging system. Before we get into what makes up a streaming platform, let's take a step back and talk about the simple concept of a publish-subscribe message system pattern. In this pattern, the sender does not send data directly to the receiver. Rather, the sender classifies the messages without knowing if there are any receivers there to receive the messages. Likewise, receivers subscribe to certain messages from a certain class and do not know if there's any senders actually sending these messages. Brokers are used as a way to store and retrieve messages. They decouple publishers and subscribers and offer greater flexibility in the types of data that are published. Brokers not only abstract the roles, they offer many performance benefits, like reducing the number of connections between publishers and subscribers, and make it easy to scale out brokers as demands increase. Kafka is an open-source publish-subscriber messaging system. In Kafka, producers are publishers or senders of messages, and consumers are subscribers or receivers of messages from topics. Kafka implements what's known as a distributed event log, where messages are always appended at the end of the log and provided in offset value. These messages are immutable, meaning they can't be changed. However, they can be read starting from any point in the log by leveraging the offset value. This can be useful in scenarios where the reader is offline for a certain period of time, and upon reconnecting, they can effectively catch up to the present state. Kafka acts like a database in some ways, in that it can store and retain messages for a specific period of time. It is this retention policy that makes Kafka different than other messaging systems. Kafka is used in many use cases and unique customers worldwide, including real-time data systems and data pipelines. Let's consider an ETL scenario. ETL is very batch-oriented. It's time-consuming and not real-time. So reports done at the end of the day by ETL are already out of date. Kafka can be used in a real-time ETL process where reports can be updated as data flows in. When using change data capture, here we get event data based on some change, like a new financial security value or a change to that reading. And with Kafka, we can look across heterogeneous data sources of these changes and store them in an ordered, scalable, and highly persistent fashion. Finally, when using Kafka as part of a big data movement, you can ingest and process extremely large amounts of data, such as IoT sensor readings. Kafka gives you the scalability of a file system, such as processing hundreds of megabytes for throughput, supporting many terabytes per server, all on community hardware, all with the strict ordering and persistence of a database system. So let's dig a bit deeper on some of the fundamental concepts and discuss topics in a bit more detail. We already mentioned that messages are written to topics. Specifically, they are written to partitions within the topic. Each partition effectively is its own log, and the offsets within these partitions gives ordering of the messages within the partition. If we consider the scenario where we have a topic with 3 partitions, here 3 brokers or Kafka servers each will have a copy of all the partitions. Each broker will be a leader of a particular partition. This is where the ingestion scale comes into play. All writes and reads to a topic go through the leader of that partition, and the leader coordinates with the rest. If a broker fails, the other brokers will have the same data and can take up being the leader for that partition. Now that we've discussed some of the infrastructure, let's briefly talk about the messages themselves. A Kafka message is shown in the slide. The key components to be aware of are the offset, timestamp, key, and value, which is a byte array. You might be thinking, did Kafka take a lesson from Henry Ford and say you can send any message you want as long as it's a byte array? Well, sort of. To Kafka, it doesn't know or care what's in the message themselves. To Kafka, it's all just ones and zeros. This is where a key feature called serializers come into play. In order to prepare messages for transmission from the producer to the broker, we use serializers, which let the producer know how to convert the source message into byte arrays. Similarly, to convert the byte array back to the object we want, we use deserializers by the consumer. We will discuss serializers and converters more when we get into the MongoDB Connector specifics. But serializers answer the question, how can I send my JSON document or a Java object or a relational database row through Kafka? To help illustrate some of the basic concepts of Kafka and to showcase setting and configuring the MongoDB connector for Apache Kafka, I have a demo that is hosted on GitHub. This demo has a few Docker files in it that when you spin it up will actually create a 3-node MongoDB replica set, a local one. It will create and configure Apache Kafka, the Confluent schema registry, the Kafka REST service, and also included with it is a Python script called realtime-mongo. And what this Python script will do is it will connect to the local MongoDB cluster and start inserting fictitious stock data. So we will use that momentarily. Previously to the start of this presentation, I started up my Docker container. So I went through and actually did the run.sh command, which went through and started Kafka, started the MongoDB servers, and configured them accordingly. And so what I'd like to do here is just to test that my Kafka is running correctly. What I'm going to do is I'm going to issue a Kafka cat. I'm going to leverage Kafka cat tool to listen to a topic called new_topic. Now what Kafka cat is, it's an open source tool that's developed as a way to easily interact with a topic. So there are a number of ways to do this. You can use the Confluent tools. You can create your own consumer and producer, or there's tools like this that you can use to make it easy to interact and do basic operations. So what I'm going to do here is I'm going to listen to this new_topic, and I'm going to go in a different window beneath it, and I'm going to use that same Kafka cat tool, and I'm going to use the -p option, which is producer, and so I'm going to be producer in the new topic. So here it's going to say hello from the producer, and you'll notice that I did receive that message on the consumer. So I know that my Kafka service is up and running and that messages are flowing through it. In this demo, we showed a simple example of using a text string, but not all sources are text strings. There are relational databases, document databases, and many other kinds of data. How do we get data from these external systems in and out of Kafka? The answer is Kafka Connect. Connect makes it so developers don't have to build one-off bridges into Kafka. It avoids having to rewrite applications and spend time figuring out how to interconnect various systems. The MongoDB connector for Apache Kafka was released earlier this year and is one of many connectors available for Kafka. This connector eliminates the need to write boilerplate integration code and ensures end-to-end data exchange between Mongo and Kafka. With MongoDB Connector, you can now use MongoDB as a source into a Kafka topic or as a sink and pull data from a topic into MongoDB. This connector is verified gold by Confluent, and that means it has been tested within the Confluent Platform. Earlier, we talked briefly about the format of a Kafka message. Messages always contain key and values, or byte arrays. If we're grabbing data from MySQL and data from MongoDB, these are very different formats. So how does Kafka know how to handle this? Well, connectors use converters to pull data into a format that can be stored in Kafka. Essentially, these converters know how to serialize the data into Kafka and deserialize the data out of Kafka. When we configure the connector, we tell it which converter to use. Our available choices for converters are Avro, JSON with or without schema, or strings. It is important to note here that MongoDB uses BSON, which has more data types than traditional JSON. For example, decimal 128, ISO date. These are not data types that are supported in traditional JSON. When these data are serialized, we write them out in expanded form. And essentially what that means is that the data type definitions and values will be strings in the result. In the current released version of the connector, which is 1.1 at the time of this recording, MongoDB Source Connector does not define schemas, so you won't be able to use the schema registry with MongoDB Connector. You'll have to just pass this document as strings. This might change in the future, so check the latest version of MongoDB Connector for the latest information on this topic. So let's talk about the source. When using MongoDB as a source, we're taking data from a MongoDB cluster into a Kafka topic. Under the covers, the connector is using the change streams feature in MongoDB. Change streams allows application to access real-time data changes without the complexity and risk of tailing the oplog. Applications using change streams can subscribe to all data changes in a single collection, database, or at the deployment level. Change streams was a feature first available in MongoDB 3.6, and that is the minimum version that the MongoDB connector supports due to this dependency on change streams. MongoDB event messages from change streams are written to topics based on the database and collection name. You can provide a topic prefix string to be used in helping form the topic to which you write your events to. Some things to note around message sizes. Maximum size of Kafka is 1 megabyte, and MongoDB documents can be up to 16 megabytes in size. So as you can imagine, things might not fit. There is a solution to this. So check the MongoDB documentation for the Kafka settings you'll need to change. One of the settings, for example, is message.max.bytes, which tells Kafka how large of a message a producer can submit. So just be aware that your message sizes, you may or may not have to change this configuration in the future. What if you wanted to capture only a subset of the documents? Only inserts or only inserted documents that match a certain criteria. You can use the pipeline configuration setting to define a custom aggregation pipeline to filter or modify the change events output. Let's take a look at expanding our original demo a bit and configure the connectors to use the local MongoDB cluster running in the Docker container. So this particular command, this curl statement, what I'm actually doing is leveraging the REST API feature of Kafka to configure the connector. So I'm doing this on the command line, and what we're seeing here is I'm going to leverage the Mongo Source Connector class, and each key and value you can use different converters. For both of these, I'm going to use the JSON converter, and I'm not going to use JSON schemas. So I'm going to set these two values to false. I am also going to choose true to publish full document only. So I'm only going to get the actual data itself. I am not going to get the change stream metadata that's associated with the change stream event from MongoDB. I'm also going to specify my source URL. So here is MongoDB. Here's my 3-node replica set. I'm going to specify a topic name. So a topic prefix, I'm going to prefix my topic name starting with stock data. The database and collection I am going to listen to is stocks, and the collection is stock data. So when I hit enter, I'm going to get a response back from the REST API, and that's going to tell me that this source connector was configured correctly. I can also issue statements to the Kafka REST API. So here, for example, I'm just going to do a curl statement against the 8083, which is the port that the REST API is listening to for connectors, and it returns the list of connectors that are installed, and it is just the one that I had issued right there, the Mongo source and stock data. So what I would like to do now is that this is set up correctly. I'm going to issue a Kafka cat statement here. I'm going to pop open our window again. Here, I'm going to close this one out here. And I'm going to listen to our stock data.stocks.stockdata. So try that again. So right now, Kafka cat is just listening on the command line, as you can see. So if I run my Python script, I have a Python script called real-time Mongo. It is going to connect to my local MongoDB server. It's going to create 10 fictitious company names and start inserting data. And so what you'll see on the right is Kafka cat is now enumerating all of these data. So I know that the information is reaching the Kafka topic. So I'm going to hit Control-C to stop pushing data up. So we have verified this piece. So MongoDB can also be used as a sink, where we are taking data from a Kafka topic, one or more, and pushing it into a MongoDB cluster. You can also use a regex string to match multiple topic names. With a sink, we are leveraging the offset value such that messages are written out to the sink, or as the messages are written out to the sink, the pointer moves until it hits the end. Given this design, it's resilient to failure or network delay, such that if the sink was reading messages off of a certain topic, a network event happened, then when that sink comes back online, it can continue where it took, where it last received that message, and can proceed forward until current time. So let's take a look at taking our demo, expanding it a little bit more, and defining a sink. So we can take data from our topic that we originally stored those stock data symbols in, and take that and push it into MongoDB Atlas. So here what I'm going to do is I'm going to issue another statement against the REST API. And this one is slightly different. I'm going to specify the topic. So stockdata.stocks.stockdata, that is the name of the topic that we originally wrote our stock data to. I'm going to specify the connection URL. So this is the connection string to my MongoDB Atlas cluster. A database, a collection name, and also, as you saw before, the same key and value converters I am using, the JSON converter without schemas. So I'm going to hit enter. That's going to create that REST API call. The sink will be configured, and you'll notice that I do get a return from here. Now, if I jump over to my Atlas cluster and I click on my stock data, what you'll notice is that the data was sitting on the topic. And as soon as I defined that sink, it actually started taking that data down and writing it into MongoDB Atlas. So here's the data that was there in the topic waiting to be processed. So this is all of the data that I had just received. So what are we announcing today? The MongoDB Atlas connector, the MongoDB connector for Apache Kafka, the one that you just witnessed me demo and so forth, that is now available in the Confluent Cloud. And here with me today, I have Jeff Bean from Confluent to tell us more about the Confluent Cloud and the MongoDB Atlas connector for the Confluent Cloud. Jeff?
Thanks, Rob. As a quick review, Confluent was founded by the creators of Apache Kafka, and as a company, our goal is to put a complete event streaming solution at the center of every business. This isn't just Apache Kafka, but also application development and stream processing capabilities, security features, easy automation and deployment, and so on. Plus, our partner ecosystem delivers a robust set of connectors for our platform, allowing not only connectivity, but also availability to use our platform for interconnectivity amongst themselves and each other in a standard and manageable way. Like MongoDB, we offer our customers a freedom of choice to self-manage our platform on-prem or in the cloud, or opt for a fully managed service. The MongoDB Connector has been available on Confluent Hub since the summer of 2019 in a limited availability release, and it went GA a few months back. Confluent ran most releases of the MongoDB Connector through our verification process. But in addition to Confluent Platform, we also offer a fully managed service with Confluent Cloud. This brings the reliability, performance, and elasticity of a cloud service for users of Apache Kafka. It also lets new users of event streaming generally move all the way from a sandbox to production level scale, where price scales with usage. Confluent Cloud offers these components of Confluent Platform: schema registry for future-proof and backward compatibility of data schema. For the purposes of MongoDB, schema support is still pretty minimal since MongoDB is explicitly schemaless. There are ways to map schema between the two, but these are mostly best practices to be discovered and to be documented for now. We also offer KSQL for stream processing and a subset of available connectors. The announcement today calls out the MongoDB Atlas connector in Confluent Cloud. For our demonstration, we'll start with a cluster launched in Confluent Cloud and a database in Atlas. We'll produce stock ticker data to Atlas, which will appear in Confluent Cloud using the MongoDB Atlas source. Then we'll use the MongoDB Atlas sync to move Kafka data to Atlas. First, I'm logged into Confluent Cloud, and I'm going to go ahead and create a Kafka topic. This topic is going to capture stock data from MongoDB, so I'm going to go ahead and call it Mongo stock data. This is going to match the collection name that I'm going to be working with in Atlas. You can also see that I have two terminal windows here. This is just to show that I don't have to use the Confluent Cloud web UI in order to work with it. The CLI is actually very helpful. I've already done the security stuff like generating an API key for Confluent Cloud and registering it with my CLI, and I've also logged in. So now I can use it. I can quickly configure and launch my MongoDB connector using a configuration like this one. In this example, I'm naming the connector mongodb.source. I have my API key and API secret that I'm using to log into Confluent Cloud. I have a topic prefix that I'm going to be using to write data from Atlas into. I have a connection host and user and password. This information is my MongoDB host name and authentication information. And then I have the database and collection information that I'm going to be reading from on the Atlas side. I'm also specifying some parameters for my connector, specifically how long I'm going to wait to batch this data up. So every half second in this example, I'm pushing the data from Atlas over to Kafka, or every 1,000 documents that appear in this on the Atlas side. I have copy existing set to true. That's super useful if I want to move any existing data that's in Atlas before the connector launches. Now I'm going to just go ahead and launch this connector. So while the connector is launching, I'm just going to show you that I'm logged into MongoDB Atlas. And it's a pretty vanilla installation. There are no collections defined, and everything is pretty straightforward. I can use the Confluent Cloud Web UI to get the current status of my connector and see that it's actively provisioning. And I can also go and see it in the connectors page on Confluent Cloud. So now that the connector is running, I can go ahead and take a look at the connectors page. And see my MongoDB source up and running. I can take a look at the settings of that and see the configuration information that I specified in my config file. Now I'm going to go ahead and run a script that is going to launch generate a bunch of stock data for me and put it into MongoDB Atlas. And at the same time, I'm going to run a consumer over on my other command window to show me the data that's in the Kafka topic. So I'm going to go ahead and say cloud Kafka topic consume mongo.stock data. So I'm launching my Kafka consumer. And I'm going to be launching my stock script. There we go. So this stock script is actually writing out to MongoDB. And as you can see, my collection data is popping back into Apache Kafka. And you can see this is all formatted in JSON with the data that's being generated by the script. That's that Atlas collection that I was just running that was showing empty. That collection is now present. And I can see the data that's actually been populated here as well. Now the data is streaming through Confluent Cloud. I can do all sorts of things with it, ranging from processing this stream using KSQL, enriching it with streaming data from another source, feeding it back into MongoDB, or any other data sync. To complete this picture, let's use the sync connector and push data from Kafka back into Atlas. First, I'll go into the Confluent Cloud UI, and I'll add a topic. And in this case, I will just call it data for Atlas, because this is data for Atlas. I've stopped my consumer, and I'm going to use the Confluent Cloud UI to launch the sync connector. Now the connector has been launched. Let's take a look. I'm provisioning my sync connector. Let's stop this. And we are provisioning. Provisioning my sync connector. Now the sync connector is running, and I'm going to take a look at that connector's config in the Confluent Cloud UI. Here we have, we're reading from the data for Atlas connector, using the MongoDB Atlas sync connector with our Kafka Connect, with our Kafka API key and secret. We're going to be expecting JSON writing to my Atlas host to a data collection named Kafka with one task, and we're going to go ahead and take the defaults on everything else. I'm going to go into the topics UI. I'm going to find my data for Atlas topic, and I'm just going to go ahead and produce some data there and watch it appear in MongoDB Atlas. So I'm going to use my production little interface, and I'm just going to go ahead and produce a row. I'm going to produce another event. And we'll go ahead and produce a third event. Now the sync connector is running, so I expect this data to appear in MongoDB Atlas. Here it is. Here's my Kafka data. And here are the 3 records which I have just produced. And there we go. We've successfully used the Atlas connector hosted in Confluent Cloud to replicate a stream of data to Confluent Cloud, and we've sourced data in Kafka and propagated it back to Atlas. As limitations today for the preview, there are a couple of things to consider. One, this is a MongoDB Atlas only connector, and that's going to be the case through production as well. So if either side of the Kafka or MongoDB connection is self-managed, if you're self-managing your MongoDB server instead of using MongoDB Atlas, or if you're self-managing Kafka, you can't use the connector in Confluent Cloud. You have to manage your own instance of Kafka Connect. Another thing, for the purposes of the preview, for the source and the sync, you need to define public access in Atlas. So you need to go and open up to 0.0.0.0/0 to allow this to Atlas. And this is because of a limitation in Confluent Cloud where public IPs are not yet exposed in a way that you can specifically limit your Atlas access to Confluent Cloud. Hopefully we'll be working with that to get that resolved before dev. On the source side, the output of the connector from Mongo will be string. So if you try to use any other converters to convert that data to other things other than string, you're going to get issues. So stick to casting your data types as string. We also have a 1 task per connector limitation. So I wouldn't pump a ton of data through this. This is limited to one task, 1 thread on the connect side. And also for the source, just in order to get this working and get this functioning correctly, we've removed the pipeline parameter. So the ability to query Atlas in more detail or to build an aggregation pipeline on the Atlas side and specify that on the Confluent Cloud side isn't there on the preview. It should be there before the GA. On the sync side, the MongoDB Atlas and Kafka cluster, your Confluent Cloud cluster and your MongoDB Atlas cluster must be in the same cloud provider and the same region. And this is mostly to save you costs of having to move lots and lots of data from Atlas from Kafka into Atlas. And also the public access and 1 task to connector limitation also applies. So it's great to get started. Just don't go thinking you can build a aggregation pipeline yet, and don't move more data than is provided by that 1 task per connector limitation, and have your 2 clusters in the same region. If you want to know more, not just about Confluent Cloud and Confluent, but the Confluent and MongoDB partnership generally and how that shakes down from a technical level, take a look at the reference architecture for Confluent and MongoDB. This is a joint document that was published by Confluent, developed in conjunction with MongoDB, and is available on the Confluent website. It's a great document for contextualizing the entire partnership, for mapping concepts between Confluent and Mongo, between Kafka and Mongo, for understanding how we recommend moving data and thinking about moving data between the two, and for providing all the resources that you might think are important. Things like joint blogs, things like thought pieces, things like education, and so on. So to wrap this up, Rob talked a little bit about Apache Kafka and Kafka Connect, what Kafka is, what Kafka Connect enables you to do, how you integrate Kafka with external systems like MongoDB, how Kafka is at the center of Confluent Platform, which is a real-time event streaming solution for enterprises, how we host an instance of Confluent Platform in Confluent Cloud, It runs fully managed as a service in all 3 public cloud providers, and that the MongoDB Atlas connector is available now in preview. And you can easily demonstrate, or you can easily connect your Kafka applications with MongoDB Atlas. And there's a reference architecture. And I hope you enjoyed the demo. Thank you.